Hello, this is Canary and Coal Mine Designs. I'm Nathaniel Soderberg along with Jeffrey Weiss, Zachary Toffness, and Avish Menon. Our mentor is Hugh Barnaby, and we've been working on a mobile radiation detection device. We are working on specifically the interrogator for this device. The main three components we need for this interrogator are a trip signal generator, a transmission and receiving stage, and a processing stage for the return signal after the reception. The main thing we've been working on is the trip signal generator still. We've looked in a little bit to the different antennas, but haven't solidified a choice yet on that. For the trip signal generator, we originally were planning on a 1 to 10 gigahertz frequency range, but have since dropped that down to 3 to 7 gigahertz. That was about the max we were getting with the designs that we were trying out. And for the carrier for the chirp signal, we've originally had 100 nanosecond period. That's gone up to about 1 microsecond just to get rid of some glitches in the sawtooth generator used as the carrier. And Zachary's going to talk a little bit more about the progress that still needs to be done with our simulation and design.
Thanks, Nathaniel. All right, my name is Zach, and I'll talk a little bit about where we are with the simulations and where we need to be in the upcoming semester. So far we have gotten to successfully create a sawtooth waveform using a 5x5 timer, which has a period of 1 microsecond, and we have actually gotten a designed VCO that allows us to get the output chirp signal between 3 and about 7 gigahertz, which is what we are now aiming for. The couple of problems that we're having right now is the carrier frequency of the chirp signal, or of the sawtooth waveform, is carrying a little bit through to the chirp signal that is being generated by our VCO. So we are going to be looking into also some off-the-shelf VCOs that we might be able to use in order to deal with that problem and see if we can get a nice clean frequency out of it. We also are going to be looking into simulating the antennas themselves so that we can pick a good design for them and decide what directionality we want, as well as focusing some of our attention, more of our attention, onto the reception circuit so that we can have the entire thing ready to go at the same time. Mainly deciding on how we're going to be reading the input power and matching it up to the time domain of the sawtooth so we can see what our VCO is producing that power change. Next up is going to be Avish, and he's going to be talking about a few different ideas of the budget that we have for the project.
Now that you've heard a little bit about what we've accomplished and what we have yet to work on, we can talk about the budget. When coming up with the budget, there were 4 different builds that we had to consider. One variant was whether or not we wanted to include a circulator, allowing one antenna to act as both a receiver and a transmitter, or whether we wanted to simply have 2 antennas and some RF blocking material. The other variant was whether or not we wanted to include a VCO that was pre-built, or whether we wanted to design and build our own. The circulator had a much bigger difference in the budget, as those cost anywhere from $300 to $1,000 or even more, whereas just in 2 antennas and the RF blocking material costs from $15 to $35 total. The VCO didn't have nearly as much of a discrepancy, as the pre-built one costs from $20 to $30, and the designing and building our own costs from $4 to $12, depending on how many op-amps, resistors, and capacitors we end up using. So depending on which of these builds we end up going with, the budget is going to change significantly, so that's something we've been taking into account during the design process. Next up is Jeffrey, who will go over our plans for next semester.
Thanks, Avish. So like the rest of the team was saying, we have made significant progress throughout the course of this project. But looking to the future, we need to be able to complete the chirp signal and make sure that it will work in simulation. Past that, we have to be able to match an antenna so that the signal will be able to be transmitted and also received, so that analysis can be done to the received signal that comes back. After that, once we have an antenna matched to the circuit, we need to order the parts, and then with the parts we need to build that on a breadboard. Once that is complete, we can begin the testing phase, and being able to have it built on a breadboard is a major milestone. Also, completing the testing of the circuit is another major milestone. And once that is complete, we'll be able to ship the circuit off to be able to fabricate our printed circuit board, which is our final milestone. So in conclusion, we've made great progress up to this point, but there's still a lot of work to be done, and we're ready to do it. Thanks from Canary and a Coal Mine Designs.